Today, let's talk about variability. Variability uses three different types of measurements. It uses standard deviation, range, and variance. It tells us how much data points in a set of numbers are different from the average or mean value, as well as how much these data points differ from each other. So variability tells us about the difference between scores, the variability between scores, how spread out the scores are. So it is quite different from central tendency in the sense that central tendency tells us about the similarities between scores, and variance tells us about the difference between scores. When we're talking about variability, there are three different types of measures that we will see. The first of which is the standard deviation, which is the average amount that a set of numbers is away from the mean. This will help us figure out how far away most scores are from the mean. It is the most commonly used form of variability, and that's because it uses all the scores in a distribution or set of numbers. And when you calculate your standard deviation, you can't get a below zero value because you can't have less than zero variability, less than zero difference. So when you look at our formula over here, we already know that our N value is how many people we have in our study or in our research. We have our M here, which is the mean. And for standard deviation, we're going to square that. And we have a new symbol here, which is the EX squared, which is the sum of x squared. And I will show you how to find that out in just a second. When we're looking at variability, we also are going to deal with range, which is the difference between the highest and the lowest value in a set of numbers. This is the least useful mode of variability because it basically just shows us the body of scores. It just shows us just the difference between the highest and the lowest score. But it is useful in the fact that it shows us what the highest and lowest score are. And the last measure is going to be variance, which is also known as the mean square deviation, which I will explain a little bit more once we solve a problem. The variance measures how spread out the scores are as well. All right, let's go ahead and do an example problem. Workers at Google were asked how much money they put into savings each month. Find the mean, standard deviation, range, and variance for the following dollar amounts. Now, before we got started, I went ahead and wrote out what formulas we need for the stuff that the problem is asking for. So I wrote a formula for mean, and I wrote a formula for standard deviation, and I went ahead and wrote a list, too, of what the problem is asking for. So I've got the mean, the standard deviation, range, and variance. So let's go ahead and look at our formulas and see what pieces we need in order to solve those. So we need this value here, the EX value. We also need an N value. And then we need a new value of this right here, this EX squared. Now, looking at these two values, they look really similar. Do not take this value and just square it. That is not going to give you this answer. This is done a little bit differently than this one. So I will show you exactly how that's done. So let's start off. Let's do the easy stuff. Let's find out our N value. Let's find out how many participants we had. So since each of these is an X value and each X value represents one participant, let's count how many numbers we've got. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, so our N value is 10. Let's go ahead and find our range as well. Our range is just going to be the lowest score subtracted from the highest score. So our highest score looks like 21, and our lowest score is 5. So when you subtract 5 from 21, that gives you 16. So our range is going to be 16. Let's go ahead and erase that. Okay, let's find this value here, the EX value. Now, if you remember from central tendency, this is just the summation of the X values. And since all of these are X values, we have to add all of these up. So when we add up all of these numbers, that is going to give us a value of 127. Okay, so we can go ahead and put that there. Now we have the pieces that we need to solve for our mean, so let's go ahead and do that. So we have 127 as our EX value. We have 10 as our N, so that's going to give us 12.7. So we have 12.7 for our mean. Okay, now let's go ahead and find this value. Now, it says in the formula, the symbol says the summation of x squared. So since all of these are x values, we need to square each of these values and then add them up. So we need to square 15, which will give us 225. We need to square 20, which will give us 400. 5 gives us, 25. 10 gives us 100. 15 gives us another 220. Oops, not 222. 225. So we got 36 and 100 again and 64. Okay, so now that we have squared all of those, now we add all of these up, all those numbers, and that's going to give us this value here. So when we add all of those up, that gives us 1905. Okay, and now we have enough of the pieces to go ahead and solve for our standard deviation. Okay, so let's plug in those numbers. So we've got 1905 for our EX squared value. We have 10 for the N value. We're subtracting the mean of 12.7 and we're squaring that, and then all of that is square root. Okay, so let's go ahead and divide 1905 by 10. That's going to give us 190.5. When we square 12.7, that gives us 161.29. And then when we subtract those from each other, we get 29.21. Now this value here, this is our variance. So go ahead and write that in here. We've got 29.21. And then when we square that out, we get 5.4046. And since we round to this value here, and this number is less than 5, this number stays the same. So that's going to give us 5.40 as our standard deviation. Okay, now earlier when I was talking about the mean squared deviation, that is in reference to the variance. So if you take this value here, so you take 5.4046 and you square that, that is going to give you 29.2097. We round to this. So since that's above a 5, that gets bumped up one more. So we have 29.21. So that's why the variance is called the mean squared deviation, because this is our calculated deviation and we square that to get the variance over here. However, if you round and then square this amount, that isn't going to give you the variance. You have to do this amount here before rounding. So that's why it's just easier just to take this value right before you solve do your last step and solve for your square root. Just take this value and then just plug that into your variance value. And that's it. That is finding the standard deviation and mean and all that for variability.